Good afternoon, class. Here's chapter 8, further applications of trigonometric functions, section 8.4, polar coordinates, equations, and graphs. We've covered the law of sines and cosines, polar coordinates, and now equations and graphs. The objectives are to identify and graph polar equations by converting to rectangular equations, test polar equations for symmetry, graph polar equations by plotting points. Reminding everybody of trigonometric identities. It's a unit circle, x squared plus y squared equals 1. And in the case of a circle, x squared plus y squared equals r squared centered at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared centered at h and k. Fundamental identities such as Pythagorean identities, quotient identities, reciprocal identities, even and odd properties. All trigonometric functions are odd except cosine and therefore secant. In a right triangle, a plus b adds up to 90 degrees and a squared plus b squared equals c squared. Sine law indicates that sine a over a equals sine b over b equals sine c over c, and cosine law says a squared equals b squared plus c squared minus 2bc cosine a, resulting in cosine a being b squared plus c squared minus a squared over 2bc, which means cosine law is really the extended version of the Pythagorean theorem, or Pythagorean theorem is a special case of it. So what did we learn about polar coordinates? In a two-dimensional coordinate system, each point on a plane is determined by, number one, rectangular format x comma y, a distance from the y and x axis, or polar, number two, a dip r comma theta, a distance from a reference point called a pole. When you look at a rectangular coordinate system, the positive x-axis is called the polar axis and the origin is called the pole. A distance from a reference point called the pole and an angle from a reference direction called the polar axis. So if we put them together, a point P has coordinates x comma y or r comma theta. What is the relationship between the two? Rectangular has coordinates x comma y, polar has coordinates r comma theta. X squared plus y squared equals r squared. Tan of theta is the opposite y over the adjacent x, and you have to adjust for the quadrant. And if you want to go from polar to rectangular, x is r cosine theta because cosine theta is the adjacent over the hypotenuse, and y equals r sine theta. Polar, which is represented with r comma theta, can be represented infinitely many different ways. How do you do that? You can stick with r and add 2k pi, or you can change the r to negative r and add odd multiples of pi. That means theta plus pi plus 2k pi. This is two k plus 1 times pi, which is an odd multiple of pi. So rectangular and polar grids. We are familiar with rectangular grid, x comma y. Here's a point 1 comma 2. Here's a point 3 to the left, 1 up, negative 3 comma 1. Here's a polar grid. The way the polar grid works, you have the polar axis. And again, if you put them together in essence, the y-axis is having the equation theta equals pi over 2. And then you draw circles, concentric circles. And for example, this is r equals 1, r equals 2, r equals 3, and so forth. So if you want 2 pi over 4, First, you come up with the angle pi over 4 and you count 2 tick marks. You want 5 pi over 4. First, you find 5 pi over 4. Okay, this angle. And then you start counting 4. 1, 2, 3, 4 tick marks. A polar equation of a curve is the one expressed in polar coordinates and written with r as a function of theta. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. These equations may demonstrate different forms of symmetry around the axis. Example 1, identifying and graphing polar equations. Reminding everyone, x equals r cosine theta, y equals r sine theta, x squared plus y squared is r squared, tan theta equals y over x. Identify and graph the equation r equals 3, convert to a rectangular equation. Well, the technique when you have r equals a number is to square both sides. When you do that, r squared equals 3 squared. So what is r squared? X squared plus y squared. So x squared plus y squared equals 9. What is that? It's a circle with radius squared of 9 or 3, or x squared plus y squared equals 9. Reminding you, it's a circle. X squared plus y squared equals r squared, has center at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared, has center at h, comma k. So r equals 3 represents a circle with the center at the origin or pole with the radius of 3. Here's the pole or the origin, and here's the circle with radius 3, 1, 2, 3. So you have those circles. What I want to add is that understand 0 degrees, 15 degrees, or pi over 12, 30 degrees, or pi over 6. So we have them in degrees or in radians. We need to understand both. Before anything, take a look now. We have the same thing now with radians. Normally we use radians. Identify and graphing polar equations. Identify and graph the equation theta equals pi over 4, convert it to a rectangular equation. And again, reminding you of what we have seen before. So what happens when you have theta equals a number, a fixed number? Then we are going to take, here's the technique, take the tangent of both sides. So tan of theta becomes tan of pi over 4 tan of theta can be replaced with y over x. We know tan of pi over 4 is 1. Therefore, y equals x, the cross product. And theta equals pi over 4 represents a line through the origin y equals x. So if you look at this one, y is the product of tan of theta times x. where tan of theta, when they give you theta, is a number. Okay, so that's the line through the origin, power 4. Identify and graph the equation r sine theta equals to, convert to rectangular equation. Again, pay attention to polar axis and so forth, and the line power 2 here. So r sine theta equals what? Replace the r sine theta with y. What is y equals to? That is a horizontal line. Y equals -2 down here. Y up here, y equals 2 is a horizontal line. So 2 tick marks up. And there you have it. It's a horizontal line. So pretty straightforward, everybody. All right. R cosine theta equals -3. Replace it with x. And what is that? That's a vertical line, everybody. That's a vertical line. So x equals -3. So you go 1, 2, 3 to the left. And that's a vertical line. We want to identify and graph the equation r equals 4 sine theta and convert it to rectangular equation. Whenever r and either sine or cosine are given, the technique is to multiply both sides by r. That's the technique to find out what type of a rectangular equation we have. So what happens? Left side becomes r squared, and this becomes 4r sine theta. R squared, x squared plus y squared equals r squared, can be replaced by x squared plus y squared. R sine theta is y, so this must be 4y. One more time. R squared can be replaced by x squared plus y squared. R sine theta can be replaced by y. We're going to bring everything to the same side and put the 4y next to y squared. And now we're going to do completing this square by writing the following. Is -4. Divided by 2 is -2. Squared is +4. We are going to add 4 to both sides. And so over here, we use the variable which is y with b over 2 minus 2. So this would be y minus 2 quantity squared. The rest are unchanged. Therefore, we are here. We have a circle centered at 0, 2. radius square root of 4 over 2. So when r is 4 sine theta, that means x squared plus y minus 2 quantity squared equals 4. And that means we have a circle centered at 0, 2 with the radius 2. So 0, 2, this is 1, this is 2. And then a circle with radius 2. Again, square root of 4 gives you 2. So we can recognize the graph. Sometimes we can't, but these are some graphs we should recognize. So r equals 4 sine theta represents a circle. That means r equals something times sine theta represents a circle. That's the meaning of it. How about r equals negative 2 cosine theta when it converted to rectangular equation? Use the same technique as the previous page. If r is equal to sine or cosine times some number, you multiply both sides by r. This becomes r squared. This is minus 2r cosine theta. So that would be the technique, everybody. Again, replace the r squared with x squared plus y squared minus 2. R cosine theta, replace it with x minus 2x. Move this to the left next to x squared. And now we're going to complete the square here, which means this is b. Divide by 2 is 1. Square root is 1. So we are adding 1 to both sides. And this is the variable, happen to be x, and b over 2 happen to be positive 1, so plus 1 quantity squared. Okay, everybody? So whether you're dealing with this or this makes no difference. You're dealing with a circle centered at negative 1, 0, radius square root of 1 over 1. So this represents a circle centered at negative 1, 0, according to this, with the radius 1. So this is 1, this is negative 1, okay? And then a circle. And the radius of this circle is 1, and we are done. So what did we learn? What did we notice so far? Here, when r is equal a number, a constant such as a, we are dealing with a circle which is centered at the pole with the radius a. When theta is equal to something like alpha, then the line y equals tan alpha times x. This is a line, the slope is tan of alpha, and it goes through the origin or pole. When we have r sine theta equals a number, that is the horizontal line y equals a. When we have r cosine theta equals alpha, that's a vertical line, x equals a. In all of these cases, r is equal to plus minus 2a cosine theta or plus minus 2a sine theta, and we are assuming a is positive. Then they are all representing a circle, okay, where the radius is a in all of these cases, half of this, okay, half of this in an absolute value. Center For the cosine 1 is along the x-axis. In this case, a0. In this case, minus a0. For the sine is along the y-axis. In this case, 0a. In this case, 0 negative a. Symmetry. I hope you remember we had odd and even symmetry with respect to rectangular coordinate system. Now, symmetry with respect to WRT, the polar axis or the x-axis. If in the polar equation r comma theta, if in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis, in essence, the x-axis. R theta and r minus theta. If you flip this over with respect to x, that's what you get. Symmetry with respect to the line theta equals pi over 2. In other words, the y-axis in essence. If in the polar equation r comma theta, if in a polar equation r comma theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2. So r comma theta, r comma pi minus. What about the symmetry with respect to the polar, the origin? If in a polar equation, r comma theta can be replaced by negative r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole. That means you check this one. If it fails, you check this one. If both fail, then it's not symmetric. So r comma theta is the same as negative r comma theta. So theta, if we replace it with theta plus pi. Because minus r theta is the same as r and theta plus pi. All right, graphing polar equations by plotting points. Cardioid, because it looks like a heart. Graph 1 minus sine r equals 1 minus sine theta. And I'm reminding you of the symmetry. We are going to check the symmetry for practice. And then we are going to graph this by plotting points. Just like any other graph that we did before, in the beginning, what do? We plot points and we graph the shape of interest. So in this case, we are going to replace the theta with negative theta to check the symmetry with respect to the x-axis or polar axis. As you know, sine is an odd function. Therefore, this is negative sine theta. This makes it positive. Is this, so what you're looking for? Is this identical to the original one? The answer is no. So the test fails. Now we go with the second one. Replace the theta with pi minus theta here. And then sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So this part becomes sine pi cosine theta minus cosine pi sine theta. Again, everybody remembers the identities that we have discussed. Well, this is, of course, minus. So here for minus. Sine of pi is 0, as you know. Cosine of pi is negative 1. So what do we have here? This goes to 0. This one is negative times negative times negative makes it negative. So 1 minus sine theta. So it's identical to what we started. So the graph is symmetric with respect to theta equals pi over 2. Pretty straightforward, everybody. Now let's do the next one. We are going to change the r to negative r to see if it's symmetric with respect to the original pole. And so if I multiply both sides by negative, this becomes r, this becomes minus 1, this is plus sine theta. Is this identical to this? The answer is no. So that is not working. Let's also do the second part because you have to check both of them. And that means replace the theta with theta plus pi. And we've done this already here, but all you have to change this to a plus sign, everybody, okay? Sign of pi minus theta is given. Now it's pi plus theta in essence. You can think of this as pi minus theta, think of this as pi plus theta, okay? And so we end up with this cosine of pi, let me. So cosine theta, cosine pi, it's negative 1 and sine pi is 0. And so this goes to 0. Negative and negative gives us positive 1 plus sine theta. And as you can see, is this identical to the original one? No, it's not symmetric with respect to the pole that fails. So we have this symmetry only. And so we can graph this, okay? And we mentioned that, and we showed that the graph is symmetric with respect to a power 2. So the right half and the second half, the left half are the same. But as far as, plotting points is concerned, we're going to write theta, r equals 1 minus sine theta, and r and comma theta. So we pick easy numbers, common arcs. Everybody must know trigonometric functions of common arcs. So for 0 as an example, this becomes 0, we get 1. For pi over 6, sine is 1/2. 1 minus that is 1/2. For pi over 4, you get 1 minus square root of 2 over 2. For pi over 3, 1 minus square root of 3 over 2. For pi over 2, sine is 1. 1 minus 1 is 0. 5 pi over 6. The same as pi over 6. In the second quadrant, sine is still positive, so the same 1/2. 1 minus 1/2. Pi, sine is 0. So 1 minus that, it remains as 1. 7 pi over 6, the same as pi over 6, but in the third quadrant is negative. So 1 minus negative 1/2 makes it plus 1/2 makes it 3/2. 3 pi over 2, it's negative 1. With negative makes it positive 1. With 1 becomes 2. 11 pi over 6, the same as pi over 6. Okay, but negative or positive, it's negative because in the fourth quadrant, sine is negative. So 1 minus negative 1/2 makes it 3/2. 2 pi, 0, 1. Now we're going to plot some of these points, not all of them. I'm going to go with the easy ones. For example, 1, comma, 0. 1, tick mark, comma, 0. Pi over 6 is easy with 1/2, so it's somewhere there. Pi over 2 is 0. 0 pi over 2 is here. Okay. By the way, when r is 0, everybody, pole 0 comma any angle gives you the pole. Okay, just to give you an idea. 0. When r is 0, it's at the pole. Again, I'm using the easy ones. 1/2, 5 power 6. So let's locate 5 power 6. This is 1, 2. So half of it is somewhere there. 1 pi. So obviously pi is this one and 1 is here. This is easy. 2 and 3 power 2. 3 power 2 is this one. I hope you recognize that. So 1 and 2. 3 halves, 11 power 6. You locate 11 power 6. 3 halves is 1.5. So this is 1. This is 2 in between. Okay. And 1, 0 or 1, 2 pi back. So just put them together. So just if you connect them in order, just the way you have to connect them in order. Let me see what color I want, and I'm going to erase it. So you put them in this order. Something like that. Okay. I'm going to erase my work. Looks like that. Okay. Okay. Let's look at 1 plus sine theta. You can do that. You can go through the process that was mentioned. Find the symmetry. By the way, going back here, clearly, before we move on, clearly the right half and the left half are the same. Take a look. This half is the same as this half. And that's why it's symmetric with respect to the line y equals pi over 2. So you can clearly see the symmetry. Now, for 1 plus sine theta, we can do the same thing and graph it. What I want to do, I want to quickly mention a slightly different method so you're exposed to all of it. Okay. So r equals 1 plus sine theta in Cartesian coordinates. So ignore the polar. If you were to graph it, and you all know this is not to scale. This is the graph of y equals sine theta. And now shift this up by 1 unit. And we're going to go just from 0 to 2 pi, and it looks like that. So shift this up by 1 unit. This is what you get. So we're going to look at the stages in sketching the cardioid r equals 1 plus sine theta, because it ultimately becomes what is known as a cardioid. And we are going to look at various stages of that. 1 plus sine theta, 1 minus sine theta. Those are all cardioids. 1 plus cosine theta, 1 minus cosine theta, the same thing. The idea is that when this number and the coefficient of sine are the same as far as the absolute value is concerned, it becomes equal. Okay, so let me erase my work first, and then. So we are going to go with, remember in graphing sine, there are 4 arcs. So there are 4 pieces. So we are going to see that the change that occurs as theta increases from 0 to power 2, as theta increases from 0 to power 2, or increases from 1 to 2. So this is the arc we are referring to, everybody. This portion. So what's happening to this portion? It moves from 0 to power 2. Along the x-axis, it moves from 1 to 2 along the y-axis. That means if I put 0 here, I get 1. If I get pi over 2 here, I get 2. So as we go from 0 to power 2, R increases from 1 to 2. So for theta equals 0, R is 1. For theta equals power 2, sine of power 2 is 1, we get 2. So it gives you this portion. So theta equal to 0, theta equals power 2, it looks like this. And of course, we are just going with this methodology. You can always pick points in between 0 and power 2, such as power 6, power 4, power 3. Just for the sake of argument, if you pick power 6, you get 1/2 with 1 is 1.5 or 3/2. Just as an example. Now the second piece moves from power 2 to pi, and R decreases from 2 to 1. We are talking about this portion. Of the graph. As we move from power 2 to pi, it goes from the largest value 2 to the smallest value 1. So theta equals power 2. When you put it, you get 2. And if you put pi is 0, 1 plus 0 is 1. So the second part looks like that. Again, you can pick values in between power 2 to pi. You can pick 2 power 3, 5 power 6, 3 power 4, things of that nature. As theta increases from pi to 3 power 2, or decreases from 1 to 0. We are talking about this part, everybody. In this case, we move from pi to 3 power 2, and R, which has the largest value of 1, gets the smallest value of 0. So when theta is pi, R equals 1. When theta is 3 power 2, R is 0. So we talk about this portion comes to 0. Lastly, we are here from 3 power 2 to 2 pi. Finally, as theta increases from 3 power 2 to 2 pi, R increases from 0 to 1, this distance. Theta is 3 power 2. Sine is -1 and 1 is 0. 2 pi is 0. It becomes 1. So it's this last portion. This is another methodology. I wanted you to be exposed to that, but you can always use points to graph this, and that works just as good. Of course, as always, you can check for symmetry and so forth. Clearly, the right half and the left half are identical. It's symmetric with respect to the y-axis, which is theta equals power 2. Graph R equals 1 minus cosine theta. It's a cardioid again. So first reminding that R equals A times 1 plus minus cosine theta, or R equals A times 1, A times 1 plus minus sine theta, and A is positive, passes through the pole, and it's a cardioid. Basically, the pole you set R equal to 0 to figure it out if need be. So theta R equals 1 minus cosine theta, R comma theta. And let's go with easy numbers again. We're going to plug in. Notice how fast we can do that. These are easy numbers. Plug in 0. Cosine is 1. 1 minus 1 is 0. Power 6, square root of 3 over 2. 1 minus that. Power 4, 1 minus square root of 2 over 2. Pi over 3 is 1/2. 1 minus that is 1/2. 2 pi over 3 is the same as pi over 3. Okay. But in the third quadrant, okay, it's negative. 1 minus negative 1/2, which makes it positive 1/2, which makes it 3/2. Pi gives you negative 1. 1 minus negative 1 is positive 2, and those are the pairs. So I hope you see that it's really not too bad. Just plotting points is doable. Those are easy numbers. So we are going to plot a few easy points, everybody. 0, 0, of course, the origin, the pole. I don't want to plot those because square root of 3 over 2, it's rough scale. I mean, square root of 3 is about 1.7 divided by 2.85. 1 minus that's 0.15. Let's go with the easy numbers. 1/2 pi over 3. So first, we have to figure out the pi over 3. And then go 1/2. So pi over 3, 1/2. We are assuming that each one is half. So this is 1, and this is 2, and so forth. 1 pi over 2. So up here, 1 and 2, this is 1. Okay, everybody. uh, 2 and pi. So this is pi, 1, 2, 3, 4, is 2, okay? And this is, by the way, 3/2 and 2 pi over 3. So this is it. Looking like that. If I change the theta to negative theta, because cosine is an even function, nothing changes, which makes this symmetric with respect to the polar axis. That means all I have to do just graph this like so, right? The bottom half is the same as the top half. Symmetry with respect to the polar axis. R comma theta can be replaced by R comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis. Now, you can just move on that and graph this. Let's just try it. So something like that. This is, I mean, not to scale, but that's it, and you're done. You can stick with symmetry, or you can pick up points and add points. For example, 4 pi over 3 is the same as pi over 3. In the third, that means cosine is 1/2 in the third quadrant, and it's negative. So 1 minus negative 1/2 makes it 3/2. 3 pi over 2 cosine is 0, so it's just 1. 5 pi over 2 is the same as pi over 3. 1/2, but is it positive or negative in the fourth quadrant? Okay, cosine is positive, so 1 minus positive 1/2 gives you 1/2, and 2 pi or 0 gives you 1. That gives you 1 minus 1 is 0. You can plot those pairs, and ultimately looking like that. Graphing polar equation by plotting points. Graph the equation r equals 3 plus 2 cosine theta. And we are going to, just for practice again, look at the symmetry. So first thing first, we look at the symmetry with respect to the polar axis by replacing theta with negative theta. As you know, cosine is even. Therefore, this is the same as cosine theta. And therefore, that works. The test works. It's symmetric with respect to the polar axis. Let's replace it with pi minus theta, and this is cosine alpha. Let's just write this. Cosine alpha, cosine beta, plus sine alpha, sine beta. So 3 plus 2 times cosine pi cosine theta plus sine pi sine theta. And we know that sine pi is 0, so nothing to worry about. Cosine is negative 1, therefore 3 plus 2 times negative 1 minus 2 cosine theta, and the test fails. Nothing happens there. Now let's check the last one. We are going to replace the r with negative r. And if you multiply both sides by negative, this becomes r, this becomes, let's just quickly do that. So that doesn't work. So this becomes r, this becomes negative 3 minus 2 cosine theta. Are they identical with this? And the answer is of course not. Let's replace theta with theta plus pi. And that doesn't work because I hope you recognize this as cosine theta cosine pi minus sine theta. Sine pi is 0, so the second piece is negative. My apologies, 0, and this becomes 3. Cosine of pi is negative, so it's minus 2 cosine theta. And again, this goes to 0. So that doesn't work, okay? That doesn't work either. All right. We're going to graph this, and we are going to use easy points. If I put 0 here, I get 2 times 1 plus 3 is 5. If I put power 6, is 2 times square root of 3 over 2 plus 3. If I put power 3, I get 1 half. 2 times 1 half, 1 and 3 is 4. If I put pi over 2, I get 0, so I get 3 here. If I get 2 pi over 3 is the same as pi over 3, I get 1 half, but in the second quadrant is negative. So 2 times negative 1 half, it's minus 1, and 3 makes it 2. 5 pi over 6, 3 plus 2 times square root of 3 over 2, but negative because the second quadrant cosine is negative, and pi, as you know, gives you negative 1. 2 times negative 1, 9, negative 2, and 3 is positive 1. And these are the pairs. So take a look at those. Let's plot them. Okay, so we have that. Let's go with easy ones. R comma theta 0, 5. I mean 5, 0 plus R comma theta. This is 5, 0. I thought I put 5, 0, but let me just put that. So you go with the angle 0 and you go 1, 2, 3, 4, 5 tick marks, and it gives you that. I'm not going to go with that. I'm going to go with the easy ones. 4 pi over 3. Pi over 3 is the same as 60 degrees. And we're going to go with 4, so 60 degrees. We're going to go with 4, so 1, 2, 3, 4. So again, on purpose, I'm using degrees here so you can go back and forth. 3 and pi over 2. Pi over 2 is 90 degrees. 3 would be, let's see, 1, 2, 3 here. Okay, everybody. This is easy. Find 2 pi over 3, which is 120 degrees. And then how many tick marks? 2, so 120, 1 and 2. Okay. I don't want to go with this one. This is easy. 1 pi. So pi is 180 degrees, everybody. Pi is 180 degrees, and 1 is just one of those circles. And then if you connect them, and the bottom half is the same as the top, because remember, it's symmetric with respect to the x-axis, with respect to the polar axis. Again, degrees or radians, the same. Look at those pairs, everybody. Now, of course, for the sake of argument, so you know what happens here as an example, this is about 1.73. So the sum of these two is 4.73. And that's why we have 4.73 pi over 6, just to give you an idea. Okay, 1, 2, 3, 4, close to 5. That's how you come up with others. But I wanted to go with the easy choices. Okay, everybody? We're going to continue. Graph R equals 2 plus 3 cosine theta. So theta is R. R equals 2 plus 3 cosine theta and R comma theta. We are going to go with the easy ones. 0 plus 0 cosine is 1, 2 and 3 is 5. So 5, 0. Pi over 6 square root of 3 over 2. So 2 plus 3 times square root of 3 over 2. Pi over 4 is square root of 2 over 2. 2 plus 3 times square root of 2 over 2. I want to go with the easy ones, but I'm telling you what they are. Pi over 3 is easy because it gives you 1/2. 3 times that is 3 halves, or 1 1/2, and 2 is 7 halves. Okay. Now for pi over 2 is easy because that's 0. So you get 2. 2 pi over 3 is the same as pi over 3. 1/2 in the second quadrant is negative, so this makes it 3 times negative 1/2. Negative 3/2 and 2 is 1/2. 2 minus 3/2. Pi is easy because it gives you negative 1 times 3 is negative 3 and 2 is negative 1. So you get the picture, okay? 4 pi over 3 is just the same as 2 pi over 3 gives you 1/2. 3 pi over 2 gives you 0 here, you get 2. 5 pi over 3 is the same as pi over 3, and it is positive because in the fourth quadrant cosine is positive, so it gives you positive 1/2. And times 3 is 3/2, and 2 makes it 7/2, and 2 pi gives you, just like 0, gives you 5. So the order, this has to come down a little bit, and you get this one. So pretty straightforward, everybody. Now let's go, not with all of those. Again, let's go with the easy ones. 5, 0. Why did I put 0, 5? Why? This is 0, 5, everybody. No, it is 5, 0. It is 5, 0. 5, 0. So the 0 degrees or just 0 radians, and you go 5, tick marks, 1, 2, 3, 4, 5. By the way, as far as the symmetry is concerned, if I replace the theta with negative theta, remember, because it's an even function, nothing changes, so the test works. These are identical, okay? Which means the top half and the bottom half, they look the same because they're symmetric with respect to the polar axis. So 0, 5. So that means 0 degree and go 5 tick marks, 5, 0. Okay. This is easy. Pi over 3. 60 degrees. 7/2, 3.5, so 60 degrees. 60 degrees. 1, 2, 7/2, 3.5, so it's here. 2 power 2, so up here, 90 degrees or power 2, 2, 1. When I say tick mark, 1 circle, and this is the second circle. The first circle, the radius is 1, the second one is 2. So we are up here. Okay. 1/2 2 pi over 3 would be 120 degrees, somewhere there. Maybe I did that. Negative 1 pi. Here's pi or 180. Here's 1. Because it's -1, it's on this side, everybody. Okay. By the way, if you set this equal to 0, cosine theta is -2/3, theta is cosine inverse of -2/3, and it gives you the answers. I want to explain what this means. The question is, does the graph go through the pole? And you have to set this equal to 0 and find out. And it happened to go through the pole actually 2 times. Okay, once at 131.81 degrees. And basically, if you want to know the second one, remember, if you subtract this from 180 or from pi, you get the reference arc. So let me explain this to you so you understand what I'm talking about. So for this one, reference arc, and then I will, because maybe I put it here because I don't want to erase it. Let me erase what we have here. So reference arc is 180 minus 131.81 degrees. Okay. Which is about 48.19 degrees. The other angle, okay, theta, let's call this theta sub 1. The other angle that gives you 0 is 180 plus this number, 48.19, okay? Just to give you an idea. All right, let's continue with the thoughts. 2, 3 power 2, 3 power 2 is down here. That means 270 degrees. And we said 2, so 1 and 2. Okay, first of all, that one, -1 pi is here, class. This is -1 pi. And then this is 2, 3 power 2, which means if we were to graph it, let me see what color I can use to graph this. I'm going to try to graph it with the red one. So it goes, it's a curve, goes through those. And goes through that. And that one. And then by symmetry, the bottom is identical to the top. Okay, just to give you an idea. And it looks like that. Let me erase my word so you can see that better. All right. Graphing a polar equation by plotting points. Again, graph the equation R equals 2 cosine 2 theta. That's a rows. And reminding you of symmetry. So let's start working on symmetry. First, replace the theta with negative theta. As you know, cosine is an even function. So cosine of theta or negative theta is the same. Cosine of 2 theta or 2 times minus theta is the same. And therefore, the test works. And it's symmetric with respect to the polar axis. So that's the first. Now we are going to see whether it works with respect to pi over 2. Therefore, we are going to change the theta to pi minus theta. So we replace the theta with pi minus theta. We distribute the 2, we get 2 pi minus 2 theta. As you know, the period for cosine and sine would be 2 pi. Therefore, it's the same as dropping the 2 pi, and this is the same as, let me use a different color, cosine of negative 2 theta, which is the same as cosine of 2 theta. So that works. The graph is also symmetric with respect to theta equals pi over 2. It so happened, if that's the case, where the function is symmetric with respect to the polar axis and pi over 2, it's symmetric with the origin as well. The pole. The function is symmetric with respect to the polar axis as well as symmetric with respect to theta equals pi over 2. Therefore, it makes it symmetric with respect to the pole. Now, let's again go with easy points. Theta r and r theta with from 0 to pi over 2, we pick numbers. For example, 0 gives you 0. Cosine of 0 is 1 times 2 is 2. Pi over 6. Two times that gives us pi over 3. Cosine of pi over 3 is 1/2. 2 times that makes it 1. Pi over 4 times 2 is pi over 2. Cosine is 0. Pi over 3 times 2 is 2 pi over 3. Cosine is the same as pi over 3, 1/2. In the second quadrant is negative 1/2. 2 times negative 1/2 makes it negative 2. Pi over 2 times 2 makes it pi. Cosine of pi is negative 1 times 2 makes it negative 2. And these are the pairs. So 2, 0, so 0 degrees or radians, and 2 tick marks, 1 and 2. 1 pi over 6, so pi over 6 is 30 degrees. 30 degrees, and only 1 tick mark, so one of those circles, okay? Here. 0 pi over 4. Pi over 4 is 45 degrees. But remember, when r is 0, it represents the pole, regardless of what this one is. So 0 pi over 4 represents the pole. Negative 1 pi over 3. So let's find pi over 3, which is 60 degrees. Now, when it's positive, it's on the same direction. When it's negative, in the opposite direction. And you go with 1 tick mark. Okay, so 60 degrees, the opposite direction. Pi over 2, 90 degrees, because this is negative 2 in the opposite direction. So instead of going up, you go down, 1 and 2. And if you were to connect just those points, this is what you get. Now, we really covered one arc. Remember, sine, cosine, they have 4 arcs. So 0 to pi over 2. Pi over 2 to pi. Pi to 3 pi over 2. 3 pi over 2 to 2 pi. Then it will give you the rest of it. If you go with a graphing calculator and put that in polar form, the mode must be polar. and you put 2 cosine 2 theta, it gives you a graph similar to this. Let's see if we can do this together. So we have a graphing calculator. If I click on Y, it is in, so first of all, if you look at the mode, everybody, if you come on down, see its function, parametric, polar, it's on polar, so we're fine. Second mode. Then you go to Y and you put 2 cosine 2 theta, we are fine. And then if you graph it, it brings up the graph. Let's actually clear this, and I'm going to change the mode to function. And I'm going to clear this. Second mode, I'm going to go back to the mode, put that in polar. I want to make sure that it shows you what we have. And if we go here, okay, this is okay. Let me clear that first. So it's going to graph it. There is nothing. Now let's put 2 cosine 2 theta, close parentheses, enter. And now let's graph. So it does it for you. Okay, so 2 cosine. Okay, so let me clear that. 2 cosine 2 theta, close parentheses. And now if you graph it, it shows the rows. I just wanted to make sure you can see that as it does it in order. So we've seen this. Let's look at the last part. Rose curves are characterized by equation of the form r equals a cosine n theta, or r equals a sine n theta, where a can't be 0, and have graphs that are rose shaped. If n is not equal to 0, is even, the rose has 2 n pedals. If n not equal to plus minus 1 is odd, the rose has n pedals. So when it's odd, n pedals. When it's even, 2 times that. And also we have other forms, lemniscates, and are characterized by equation of the form r squared equals a squared sine 2 theta, r squared equals a squared cosine 2 theta, where a can't be 0, and have graphs that are propeller shape.